Welcome back to Vijay Academy. In this video, let us recall the relationship between the zeros and coefficients of a linear polynomial and a quadratic polynomial and learn how to form a quadratic polynomial when the sum of the zeros and the product of the zeros are given. So, look at the first point. If alpha is a zero of the linear polynomial ax plus b, then alpha is equal to minus b by a. So 0 of a linear polynomial will be in the form of minus b by a, where a and b are the numerical coefficients of linear polynomial. And for quadratic polynomial, if alpha and beta are the zeros of the quadratic polynomial ax square plus bx plus c, then sum of the zeros will be in the form of minus b by a, and product of the zeros will be in the form of c by a, where a, b and c are the numerical coefficients of quadratic polynomial. So if you want to form a quadratic polynomial using the zeros of the polynomial, if alpha and beta are the zeros of a quadratic polynomial, then the polynomial can be formed in the form of k times x square minus alpha plus beta times x plus alpha into beta. So here where k is constant, that means um, for a particular pair of zeros, there are infinite number of polynomials, infinite number of quadratic polynomials can be exist. That means infinite number of quadratic polynomials can have a particular uh, group of particular pair of zeros. So where k is constant. So now let us learn the problems from exercise 2.2 second main. Find a quadratic polynomial each with the given numbers as the sum and product of its zeros respectively. So in the first question, sum of the zeros is 1 by 4. So let me take this as alpha plus beta equals to 1 by 4, and product of the zeros is minus 1. Now let us form the quadratic polynomial. That is, the quadratic polynomial is k times x square minus of alpha plus beta times x plus alpha into beta. Let us substitute the values here. So we get k times x square minus alpha plus beta is 1 by 4. 1 by 4 into x. So let me take this as x by 4. And alpha into beta is minus 1. So plus of minus 1 is minus 1. And now to write this in the standard form, let us multiply the whole polynomial by the LCM of the denominators of the terms. So the LCM of the denominators of the terms are the denominators are 1, 4 and 1. So the LCM is 4. So multiply the polynomial by 4. We get k times, so 4 into x square is 4 times x square, and 4 into minus x by 4. So where 4 and 4 gets cancelled and you get minus x, and then 4 into minus 1 we get minus 4. So this is the quadratic polynomial for the sum of the zeros and product of the zeros given. So second one, in the same way, sum of the zeros is root 2 and product of the zeros is 1 by 3. So alpha plus beta is root 2 and alpha into beta is 1 by 3. So substituting this in the quadratic polynomial, we get k times x square plus, minus. So x square minus root 2 times x plus 1 by 3. So again, here we have a denominator. So multiply the whole polynomial by the LCM of the denominators. LCM of 1, 1 and 3 is 3. So multiplying this polynomial by 3, we get k times 3x square minus 3 root 2x plus 1. So question number 3, it is sum of the zeros is 0, alpha plus beta is 0 and alpha into beta is root 5. So the polynomial is k times x square minus of alpha plus beta times x plus alpha into beta. So now let us substitute the values in the polynomial. So we get x square minus 0 times x plus root 5. So 0 times x is 0, therefore we can skip the term and write x square plus root 5, k times x square plus root 5. Next one, we have sum of the zeros is 1 and product of the zeros is also 1. So substituting this directly in the polynomial, we get k times x square plus x plus 1. So this is the required polynomial. And next we have sum of the zeros in the question number 5. Sum of the zeros alpha plus beta is minus 1 by 4 and product of the zeros alpha into beta is 1 by 4. So substituting this in the quadratic polynomial, k times x square minus of minus 1 by 4 times x plus 1 by 4. So let us simplify this. So by simplifying this, we get k times x square plus x by 4, because here we have minus of minus 1 becomes plus 1 by 4. So we need to multiply this to write this in the standard form. Let us multiply this polynomial by 4, because LCM of the denominators is 4. So we get k times 4x square and plus x plus 1. So next one, sum of the zeros is 4 and product of the zeros is 1. So alpha plus beta is 4 and alpha into beta is 1. So replacing these values in the quadratic polynomial, k times x square plus 4x, sorry, it is minus 4x, because the identity is minus of alpha plus beta. So we can write this as minus 4x and plus 1. Please subscribe to my channel and click on the bell icon to receive the notifications for the new videos. Thank you.